Good morning, Year 9. Today we're starting a new topic, linear relationships. Now, if we have a look at our new poster for stage 5.1, 5.2, so we're doing some from both of those. We see the 2 points here. One, a student determines a midpoint gradient and length of an interval and graphs linear relationships. And then the 5.2 outcome, a student uses the gradient intercept form to interpret and graph linear relationships. So we're pretty much going to start by going straight into this. We're going to start tomorrow with midpoint of an interview, but for today we are going to review the very first point that we had on stage 4 linear relationships, which is label and plot points. Plot and label points on the Cartesian plane when given coordinates, and read the coordinates of points on the Cartesian plane, including those coordinates that are not whole numbers. So that is what we're going to have a look at today. We're going to revise the Cartesian plane. Okay, so there's our learning intention as we just discussed. Now the Cartesian plane, remember, it is a way of graphing, gridding any point. We have our horizontal axis and we have a vertical axis. If we have a point here, we can list any point with the x and the y. The x is the vertical, so that's x, and then y is x is the horizontal, y is the vertical. Now when we're talking about these things, we've got a point here, that is our starting point, that is 0, 0, and is called the origin. So from 0, 0 starting point, the x-axis goes this way, positive numbers, this way, negative, and it goes this way for vertical, for y positive, and y negative. Now any point which is over here in this quadrant is in the first quadrant, and both x and y are positive. Anything that's here we call our second quadrant. This way our x is negative, our y is still positive. So we've got negative x and positive y. This is our third quadrant. Now third quadrant over here, both our x is negative, it's to the left of this line, and our y is negative, it's underneath this line. So we have x negative and y negative. And finally, in the fourth quadrant, our x's are positive, but our y's are negative. So in the fourth quadrant, x positive, y negative. Now, as we said, coordinates, the position of any point on the Cartesian plane, which is just the same thing as a number plane, can be given by a horizontal x and a vertical y pair of coordinates, which we put in brackets and go x, y. So having a look at an example, it's asked me to find the coordinates of the points shown. So A, if I come up here and A, there's my A. First I come across with the x till I get underneath, I find it's 3. Then I come up and I find that it's 3 across and 5 up. So my coordinates are 3, 5. If I'm looking at B, here's B here. First I go across to underneath it, I go across 6, and then I come up 3. So the coordinates of B, 6, 3. Looking for C, here it is. First x, go across to the left 2, that's negative, and then come up 5. So negative 2 across to the left and then up 5. D is here. So D, I've gone negative this way, come across 6, so it's negative 6. Then I've come up and I'm halfway between the 2 and the 3, so I'm 2.5, negative 6, 2.5. E is down here in the middle of nowhere. It's coming across this way. I've come across about 5.5, and I've come down 4.5. So E is minus 5.5, minus 4.5. Looking for F here, come across first positive 5 down 2, which is negative 5 minus 2, and finally G. I've come across my x-axis by 4, and I've come down 4.5, so 4 across positive minus 4 negative. Finally, this last one, if I'm going to plot the following points in the Cartesian plane, I'm plotting w minus 3, 2.5, so negative x this way, negative 3 is here, 2.5 is positive, come up, 2.5, put my dot for w, x 4 minus 2, so 4x positive go across, and then negative, so come down 2, there's my point for my x, y is minus 3, minus 5, so minus 3, come across 3 to the left, then go down 1.5, there's my y, and finally my z is 4, 2, both of them are positive, across 4, up 2, put a great big dot. Okay, so for today, what I really want you to do is just to revise the Cartesian plane. So find the coordinates of each point, find w, find out how far we're going to go across, minus 5, 6, so w is minus 5, 6. Just keep going and find them all. There's n, so n will be here somewhere for e. N is, I would label them if I was you, I would just put the points next to them all, rather than put them down here, label them all like this, n. So it's a positive across there, 3.5, and then it's down 3, so it is 3.5 and minus 3 because it's below the x-axis. Okay, so that's the first exercise, is to label them all. Then the next one is to write the letter naming the point described, so just go and find them, 1.5, 0, across 1.5 and staying on there. There it is, right there is E. So go through and label those points. Once, if you've put all of the coordinates in part A here, then you'll simply be able to go through. You've just about done this one anyway, really. Answer this question 3, which points lie on the x-axis? So the x-axis is this thing. We're looking for all the points which are sitting on it. So all these points here are sitting on the x-axis, and then no doubt it's going to ask us for which points are on the y-axis. The y-axis is down here. There's a point, and there's a point. Okay, what else have we got here? What is the special name for point 0? What's in your notes? What's that point? Now we want the quadrant, so please go through, remember, first quadrant, second quadrant, third Q, fourth Q. So name the quadrant in which each of those points are in, find the points, name the quadrants, write the coordinates of a point on the x-axis and the y-axis. That's pretty much the same thing here, you're just writing out the coordinates. And now on these ones, just locate them where they're meant to be of these 6 points, which one is in the first quadrant, so you're looking for positive and a positive. Third quadrant would be 1, 2, 3, it's going to be negative and negative. Anyway, you're going to go through and all that. I'm going to wipe all that off. Have a go, please.